Hello and welcome back to the podcast. It is me, Mark, and we have reconvened the design series again, but with a twist. We've got a very special guest with us who's come along to show us how software can aid electrical design, and that is Spencer Henry. So how are you, Spencer?
Awesome, thank you. Thanks for letting me come on. Appreciate you taking the time. Yeah.
No, cheers for coming on. And like we've been speaking about this through the prior recordings that we've done, mentioned we were going to try and reach towards looking at some software. So it's great that quite last minute, I think we only really decided to do this today, thanks to Craig. So we'll go down to you now, Mr. Boost. Mr. Boost, how are you?
Yeah, good. It was thanks to Spencer reminding me yesterday when I was actually doing some of my own training that this was something that we'd mentioned. But I'm good. I mean, I'm sure nobody is looking forward to tomorrow being our last day and having a bit of break over Christmas, but I
Gutted.
think I am.
It's overdue, isn't it, mate? I mean, we've been stupidly busy. We were just talking before the podcast, and I'm very much looking forward to a rest. Richard, are you finished your Christmas party and you seem to have been on like a non-stop 2 week kneezer?
Well, mate, not quite. There's an afternoon party tomorrow from 3 o'clock, so that's probably about it. But yeah, it's been a celebration really, and it's a shame that you guys don't live a little bit closer. But I know we attended a few nice events, but hopefully we can do something in the new year and celebrate all the successes of Apprentice 1-to-1 and our individual successes. It's been a good year really, and I'm looking forward to next year. A lot of good things that hopefully we're going to get involved with and push forwards. So no, all good, mate, all good. Good to see everybody again. I've missed the last couple because of, as you quite rightly say, little events and things. But it's been good. I'm looking forward to listening what Spencer's got to say because as a bit of a dinosaur, I'm still used to going through the books, which is the wrong way to do it really because
I don't know if it's the wrong way. We all have our own ways we've done for a very long time, haven't we?
Yeah.
And the software is to help us. That's how I find it. It's not to replace anything that we've done prior. It's to really help us and be more confident, I think, in design. But I'll let Spencer convince you because we and Craig are avid users.
You make a really good point, and it's actually a point worth making right now at the very beginning. Is software is only ever a tool. Yeah, it's never going to be able to replace good, competent engineering judgment. And I'll actually take you through an example on here as to why a little bit later on as well. But at the end of the day, without good electrical understanding, the ability to understand how to design and how those calculations are performing, you're never going to be able to complete a compliant design. Even if the software throws something up together and you put it together and there's no issues, no warnings, there's no guarantee that in physicality you could actually go to a site and then install that. I'll show you sort of a little bit example of that a little bit later on as well. But yeah, no, very, very, very keen point to make is it's never going to replace an engineer. It is a tool, something to help speed up the process, help you move things along quickly, and just give it a nice fully finished, nice tidy look to it, so it all looks professional. You can put together nice key information, and it's just try and takes a lot of the heavy lifting really out of the process more than anything else. Yeah,
You probably see that, do you, Craig, when you're handing out your designs to teams of electricians? If you can like mass publish them and all work from the same sort of document, it's a bit easier than handwriting and photocopying everything.
Yeah, it's good because you go through stages, and I agree. It's only as good. You only get out as good as what you put in because the screen and the software looks simple, but you've got to be putting the right parts in the right boxes. It's very easy to get errors or get situations, but from an install point of view, we can make sure that we give at the start of every job a set of cable calcs with a set of drawings, and even just on the most simplest of reports where it shows your circuit schedules, your breakers, your cable type, your size, and how long it's being calculated as an approximate run. That's what we give most of our sparks at the start of a job to go, well, you've got cleaners sockets, you're expecting to have six of them on there, you're expecting it to be no more than 50 meters, and you're installing it in armoured, clipped under the floor, and this is what you're doing. And if they go, well, actually, we're 95 meters and we've got 15 of them on site, you go, well, that's not the design that we're working to. So we need to go back to the drawing board and edit it. And as Spencer said, when I'm doing LTA design, so just getting landlord agreements to be able to get a project moving, I maybe haven't always been to the site. So what I've got on a software that's looking like a compliant design and is compliant, when my sparks get on site, they're going, this doesn't work. And you've got to go back and re-edit and remodel that. And that process is far quicker and it's built in the software and it's a case of tweaking rather than kind of restarting the whole process again. But I definitely rely on my sparks and our foremans on site to be giving back and pushing back and challenging that information so it isn't something that fixes every problem.
No, I mean that the features that are baked into 2OM are vast. We couldn't even attempt to cover it in 1 hour. And Spencer has got some videos over on YouTube with Modecsoft already, I think, and some of your own stuff, haven't you, Spencer? That's gone into quite a lot of detail. So I'll link in the description over to that. But we're going to try and give a reasonable overview of what it can do in terms of design, bearing in mind that this is an apprentice trainee-based podcast. So if you're ready, Spencer, you can pick up and share your screen and we'll run through some stuff that this can do.
Learn how to use it now.
Yeah, that's it. Back to school we go.
So I'll be there. Can everyone see that all right?
Yeah, that's great.
Fantastic. Okay. So this is like the interface where you come into ElectricalOM. There's a lot of detail in here, which we're probably not going to go too much into today. I want to really keep to the focus of sort of building the design up. So I'm going to start with simply putting in something like an incoming supply to the likes of a domestic property. I'm going to keep it relatively small. So we're just going to go for something very basic, like a single phase supply. And tools have been developed in the system, so everything's in easy access. So for instance, here I've got right click on the menu and I can access to start putting in elements. And you'll notice that the software will restrict you as we start building things up. So it won't let you put something in yet that you couldn't necessarily put in without first putting in the right detail and information detail. So for instance, first of all, we need some sort of supply. We need something to connect our system to. I'm going to go for a single phase supply, which is obviously something standard that you'll get in a domestic installation. And here we've got what people refer to as a PME or TNCS. Could also now technically be what people also refer to as PMB. Yeah, so we're seeing a lot more of these things sort of popping in there. New terminology we're seeing coming to these. Have you guys covered like the PMB, PME stuff?
We very briefly have mentioned it, but not in any great detail.
But we won't overly go into that right now. I mean, in terms of the calculation wise, it's not going to have a massive effect in terms of what we're going to be looking at upstream. Obviously, it does have a bigger effect in terms of, what you're going to be considering safety wise for that installation and those sorts of details. We've got a supply in here. And now we can start editing various information around it. Now, one of the things that I commonly get asked about is when someone's designing something for like a domestic property, they'll say, I want to put in a value like 0.35 because that's what the supplier says that we've got for the property. And what they don't realize is then later on, they get bigger problems come up in the design. And I'll talk a little bit more about that later on. But majority of the time, you can calculate roughly what the values for your levels. Sometimes you need to do diary. At the moment, this is a standard we're doing 100 kVA supply here. And then the software is calculating for you what the load capacity of that supply coming in there is. Now, that can vary depending on, obviously, the location, installation. But in a lot of cases, for single phase, if I put in, I think, 69 kVA, we calculate that, gives us a 300 amp capacity. And then you'll probably have something coming in off that and off the street, which would be, a smaller size fuse, usually 60 amp or something in place for that. And but when we put these values in, you're going to see here things like the CZE and UV values here. And actually, realistically, the values are usually quite small. I mean, if you go into majority of domestic properties in most non-rural locations like cities and towns, those sorts of things, you're going to find you get relatively low values. It's when you're going out to more rural locations, further outreaches, where you know, you're further away from city centres, those sorts of things, you will get higher values. But for instance, here I've got quite a low amount of fault current in terms of the amount of fault, and this is obviously going to be important for selecting things like protected devices a little bit later on. And then one of the common things, like I say, if I put in here my value to be 0.35, you can see that my fault level comes really, really quite low. But you've got to imagine now, when you've got a really low value like that, it takes longer and longer for a fault to build up to actually trip things like your protected devices and those sorts of things later on. So quite often, people will run the design, they'll do it on 0.35 and then have a ring circuit or they'll have a socket or a power supply out to a shed or something like that. And they're saying, oh, it keeps failing. I'm not getting my disconnection times and these sorts of things. And the reason behind it is because they put this really high earth fault value in there. And then when you go to site and you actually physically test the supply at location, you actually find it's much lower and it does pass to begin with. So this is one of those examples of engineering judgment. The software will give you information and throw things up, but it will tell you sometimes things are wrong if you haven't taken the right information or put the right detail there to begin with. So very much worth pointing those sorts of things out. Because this is basically just your fault levels against your maximum ZEs, those sorts of things. It is just very, very basically current time you did, you know, basic triangle information there, which is a calculation. It's a little bit more complex, obviously, in terms of the math, and there's additional things and impedances that you take into account there. But at its fundamental, that's what those values there are related to. So that's how we can sort of start setting up the supply. And the supply, obviously, like I say, is really important because that's going to set the tone for a lot of information later on. It's going to say how far your cable is going to run for your volt drops, those sorts of things. It's going to give you an idea of whether or not you're going to be able to use certain size protected devices. Those sorts of things. Here, currently, I've got 4 kA, but if this went above 6 kA, for instance, for a bigger supply, then you would actually need to start considering things like 10 kA protected devices in those sorts of things. So having that information right to begin with is going to be very important. Because if your values obviously in your fault levels are over the 6 kA, there's obviously the risk that you can cause damage and sap the life out of those devices that you're selecting. And a majority of domestic installations, you'll tend to find a lot of them. I think there still are these days. I've got to be honest, it's been a while since I put my hand on a tool. But
they are 6K rated.
Yeah,
you're right. I mean, it's the same principle through the paperwork side of things. You either take your ZE by inquiry or you measure it. And we get sent to do lots of surveys at a commercial level measuring ZEs for the reason you've said, Spencer, that if you put the inquired value in, it's really difficult to get some of your circuits to comply.
Exactly, yeah. On the flip side, though, it is a bit of a double-edged sword because if you do go to an installation where you're very close to something like a transformer, you might have issues with your multifunction meter actually picking up other things like reactants on the system, which effectively fools the meter into thinking it's a different result, and then you can actually have values again which are too high for the location. So if you are near something like a transformer, on the nameplate of a transformer, so for instance, just for example, if I set this to a transformer, you'll get different information that will appear within the software. I'm going to actually just do this on a 3-phase one, just to show you how that can vary quite wildly in terms of those values, because when you're doing calculations for things like transformers, there's a whole other level of math involved with that. So for instance, here I've got a standard 500 kVA supply, which is giving me about 12 kA in terms of my fault that's available at that supply there. If I change this to a transformer, then we've got things like the primary side of the calculations, which can also feed into that information, but also the impedance of the physical transformer. Now, this information is written on the transformer nameplate. Usually you'll be able to see this. It may be on the outside of the room. Might have some data sheet information, which is in your standard information. And it's often far more accurate when you're very close to transformers to actually take the information and calculate it rather than trying to do a physical read. Like say, when you're close nearby, there's lots of things that can interfere with the readings on it. And if you've got a particularly large transformer, a lot of standard multifunction testers can't actually measure high enough in terms of the fault level. So you'll get like 0.01 ohms for your earth fault. It can actually be as small as, to 2 or 3 further decimal places that you need to take that into account. So very important to understand when to test and when to use calculated information, or when it's good to use the data that's being provided by the supplier. No, more often than not, if you do it by inquiry, they will always give you the standard values that everyone hears about. So you get, for the TNS 0.8, they'll say 0.35 for your PME or TNCS systems. But you do get some, and I have come across some which do have more accurate information, but generally they tend to be for more commercial locations. They don't really tend to do that a lot for the domestic side of things. They just sort of, use the standard, values. Yeah. So yeah, I mean, here I've got a 500 kVA, and this was just based upon a standard thing. But here we've got, if I calculate this now, you can see that because I'm using a transformer, the impedance is, or the impedance of the transformer is relatively different. So I've actually got a higher fault level on this. So where I might have been able to use a 15 kA device, for instance, I can't actually use a 15 kA device now because of the type of supply and the information, the additional details we have to take into account for those calculations. So it's always important to see that. If you did want to see a little bit more information, just quickly pull up on the screen here. So, for instance, here on the website, we actually have like various information, guidance, details, and things like doing calculating fault levels. We actually go through all that information quite detailed on the website, and including how the calculations. We actually include the calculations of how those sorts of things. So if you were interested to have a little bit more of a look, it's well worth the time just to go through and have a read through, and because we explain to people how we're doing the calculations and why those sorts of things work. So people that are used to doing it by book because they're not sure how you're doing it in the software. We try to provide as much information in there, so you have that confidence, that understanding that it's all relevant to that particular type of system.
I'll pop a link on alongside the podcast for those of you who are listening or watching. You'll be able to go and check that out yourselves. And there's also a 14-day free trial as well. So if you're not a current user and you want to give it a run out, the option is there for anybody.
So I've got some basic supply information. I'm just going to go back to our single phase option that we've seen here. So I've got, very simple supply, very, very indicative of the sort of installation supply information that you probably have for a domestic installation. And I can add additional details in here as well. So for instance, I can add the information about the tails. We're going to go for domestic, so I'm going to go for 25mm conductors. We'll add a fuse in there. BSA, 361 type 2, 80 amp, for instance. And I can show additional information. So I've got some quick tick boxes here, so I can change the way everything looks in the background because we're in a CAD. We're in a CAD interface. You want to see all those fancy CAD tools and bits of information. So here I've put in some detail there. I can add some earthing. And we've got different ways of calculating things like the earthing. So here I'm just looking at it from an adiabatic equation. I can do it based upon certain tables and the regulations. We're referring to that information. So again, we'll drop that down to 60 in there. I want to press OK, leave this. You'll see that, all that information just gets thrown on there. It's added into there quite quickly. And you can see quite nicely what you've put those details as you go in there. And then we can start adding in things like our distribution boards. So for instance, here I'm going to add a single phase board. Now the software always adds in, whenever you add an item, it adds in like a conductor that feeds that. It also adds in an upstream protected device. In this case, we are going from the supply fuse. So there's also very simple tools in here. I can just turn things off like the conductor here and turn off that protected device because we're not using that in this case. Apply that information here. And you'll also note that when I get to here, look, I've got about 11 kA. So, my 6 amp devices in this case aren't going to be, sufficient for this particular installation. So, picking up information around that already. So we'll start adding that as we go. Now, everything's very customizable in terms of the detail here. At the moment, I've just got a very basic board in. It's added 4 ways here. So if I want to, I can increase the number of ways, because once you filled those ways, you will need to start adding more. I mean, these days, I think a lot of consumer units now, you're not really seeing so much in the way of things like split load consumer units anymore. It's all very much standard boards. We do have like things to be able to model split load consumer units and those sorts of things here. I have a little bit with, here's one I made earlier. And this might be useful if you are, you know, you're working in installation, which is pre-existing, and you just want to add a bit of detail, or you want to add something, or you're adding, you know, an extension out to a board, you want to show that information. So just to show that those sorts of things are possible in here. I'm not going to go too much into how to today, but there are videos on the website, like earlier on. So here's one I made earlier. I've added in, you know, fuse board. It's got a fuse on there. I've got some ways, split load board. You can see the two sides of the RCDs, those sorts of things. So you can pre-build lots of elements, which are, you know, very common. And you can save those in the software, record them anytime. So if you do common things like certain lighting circuits with certain types of cable, those sorts of details, we can add them in there.
That's really useful for us when we're adding solar PV onto systems, because sometimes they're going into additional consumer units rather than, you know, replacing the whole house one. So you can model that at a simple domestic level. That's a really good feature, actually. I wasn't aware you could do that, so that's news to me.
Yeah, there's lots of little things that are in there. I'm building actually at the moment a load of sort of pre-made templates which are going to show up in the future. Basically, it'll be things like simple socket outlets, lighting, the most common sort of installation methods you see out there for various types of location. There'll be some pre-built elements you can sort of take and drop in quite quickly and place those details as you go. So here I've got my board. I mean, generally, if you're doing a board swap now, most properties, what are we looking at? Sort of 8, 12 way?
12 to 16 ways is typical. I think they're getting ever bigger.
Let's put 12 in there. So I've added in 12 ways here, so ways. Now it's saying currently L1, because on my supply, it is just identified as L1. That's pretty standard. You might not know that information, to be honest. Leaving it as L1 or L2 or whatever, whichever of the phases you want to do. It's not, on a single phase system, it's not really going to affect much on our design. If you're looking at more of these more modern properties that are being built now, generally they'll have, you know, 3-phase boards. I've seen something now coming quite common, aren't they? So they're looking at with all the smart technology and those sorts of things, but maybe that's for another day. we'll stick
It
to
is one of those where we're kind of between two places, aren't we? I think we're hoping PV and battery storage are going to save us from needing to go 3-phase in everyone's house. But we just had a property in nearby town. They've got a 3-phase supply put in, domestic house.
Yeah. No, I remember seeing a few things. I was watching on LinkedIn. I know the guys over at eFix, they did a few videos, didn't they, where they were going into property. These were going in. So it's, you know, it is happening out there. It's something that's going on. It's all about this battery storage and, you know, prosumer and these sorts of things. We won't touch on that today, but we have, you know, already preempted a whole prosumer element going into here, which you're going to see coming into next year. There's some real magic going on in there.
Awesome.
But here, I've got various things. So here I've got basic isolator on the incomer. All these elements, they can be adjusted as we go. So for instance, this is, you know, a standard, probably going to be an 80 amp main fuse. And then you've got different AC types here in terms of the type of isolation. If you don't know what they are, again, we've got lots of really good information already pre-built in here. So for instance, for this information icon here, we've gone into the standards. We've identified what they are and what they're being used for. So you can actually then make a judgment on what you need without having to go to a different standard all the time, pick out all this various information, try and keep things simple, nice and concise as possible. So if you do come across something you might not be so sure about, you've got reference, or at least a reference to where you need to go to find that detail. I should go through there. So,
I think this is part of that. It's only as good as what you get out, because if you start speccing the wrong things, and that's what your guys are going to be ordering up and installing on site. And at the minute, there's no warnings on this, there's no errors. What you've done is not against regs, but you might be speccing the wrong equipment for your job on site if you're not looking at the right points.
Yeah, exactly that. So generally now, I'm going to go back to here. Often I think a lot of the first ways on the board now are taken up by SPDs, not
Pretty
mistaken.
much. Yeah, that's fair.
In anything modern. So again, just simple. You go in, drop an over voltage protection in here. As you can see, it's just dropped an SPD on there. I can tell it what the way is. I can add, information around the cable. And again, this is all referencing stuff back to the regulations. So depending on the type of, I mean, I'm assuming it's T1, T2 type for most domestic as a standard there. So we have sort of pre-programmed some of the basic, go-to points for these sorts of things. But it also fits out information relevant to particular types. So, if I select a cable like 2.5 with a 2.5, you see here it's going to pop in the fact that there's certain regulations that say actually you've undersized this. Go back, have a relook at it, and your warnings and things are popping up there. So everything is very, very much an interactive element there in terms of what's going on. So every time you make a change, software's going to tell you what's going on. Look at the sort of calculations going through there. So I've added some details there. And I pop this 6 amp MCB in there. Now, if I go to devices here, you can see I've got a 10K device here, but it's telling me about 11K here. And depending on the system that you're working on, obviously that's going to have quite a big difference in terms of the type of size devices, maybe even the manufacturer of devices that you're going to be selecting for that particular installation. And there's a lot of manufacturers out there. We do put a lot of them in here, and I'm actually going to talk a little bit about how that can be important as well, because it's something I keep seeing coming back sometimes with testing and those sorts of things. Generic values that we see in BS7671 aren't always the actual values for a particular protected device. The manufacturer's data can be wildly different, so we'll take a look at that as well. So for instance here, I can select some of the generic information. So we've got 15 KA. So I'm going to go for a type C, 15 KA, 6 amp on this one. And as we can see now, we've got 15 KA. And I can see against the amount of volt current I've got there, whether or not the device is going to be good. Because if I kept the 10 KA device there, it may work, but there's a good chance that you're going to destroy that device eventually if, faults keep happening, keeps tripping, those sorts of things. It's going to sap the life from that. There you go. Great. Did you have any queries before we go on? Anyone got any questions about any of that?
No, that's pretty straightforward how it drops in. I would say that usually with the SPD, we're probably going to be seeing a 32 amp breaker. I think a lot of them specify between 32 and 63, but that's here and there. And like you're going to show right now, it's super duper easy to adjust.
Yeah, so I'll drop in a 32 in there. We've got 16 mil conductors on there. So we go there. I mean, generally what we would do is we'd have a, the software will always pick the smallest device, first device in the database. So generic 6 device that goes in there. We're not really predefining those. You can predefine them yourselves, and then I can save that later on. So for instance, I've set this up now. If I right click, I can save that as a template, and then I can go into my templates as we did earlier when I pulled that whole board out, and I can pull that up at any time, drop it in. But it's up to you as the designer to set that up to begin with, to make those decisions, what needs to be there, what those elements are.
Yeah, I mean, it's going to be bespoke to the area of industry you work in, isn't it? The templates, so it's totally different for everybody, really.
Yeah. I mean, something totally different that you would fit, like maybe in the main income of a hospital, than it would be for your domestic installation. So yeah, absolutely. So we've got our SPD in there, and I can start dropping in circuits. I might start with something which we're all probably familiar with. I'm going to go for a final circuit here, and I'm going to make this something like a ring final circuit. Yeah,
the good old ring final, love it.
Good old ring final circuit. And we could have that whole debate about whether or not it's needed these days. Is it valid? I'm in the camp of we really don't need them in domestic installations anymore, but that's a whole other can of worms for another day. But rings quite common. So here I'm going to drop in, and you can select for different kinds of circuit here. And depending on what we select here, it's going to affect how the software is behaving for its calculations. So when I do select a ring final circuit, all of my calculations are going to be based on a ring. You can see it's popped up this little bit of additional information here based upon the thing that this is now a ring final circuit. And the software is also going to throw up a plethora of issues and errors because I've selected, that to be a ring. You can see these little red warning markers popping up all over the place. So for instance, if I hover over this one, saying your Phase conductor must have a CSA 2.5 or 1 mm. That's the information we put in the software. But one of the things, again, that some people don't realize is when you look at the regulation around that, the information they're setting for it is that your conductors on a ring circuit for your socket outlets must actually have a minimum current carrying capacity of 20 amps for the conductor. So the software is actually performing that check in the background. So if I choose another type of cable other than those that we saw there, what it's going to be doing is going to look in to see, right, is this current carrying capacity more than 20 amps? And if it's not, it's going to throw. And one example of where you might come across that is even with the twin and earth cable. So I go for a 70DE flat twin and earth cable. And if I hit the reference methods here, so insulation over 100 millimeters, reference method 101, yeah. Even if I have a 2.5 cable, it's only 17 amps. So that wouldn't actually comply. We would still need to have, you know, a conductor. In this case, it would have to be a 4 mil because we need to have that 20 amp current capacity in order to comply with a particular regulation in relation to that. So worth bearing in mind there. We've also
on the length of the circuit, Spencer. Sorry. On the length of the circuits when people are using this, is that length for one of the legs or is that length for the combined ring total distance?
So we're looking at combined ring total distance, aren't we? Because it's already calculating in parallel. Yeah. For the system. So our conductors are all in parallel for the system. So we're looking at the total ring all the way around from the board, going out all the way back round, back to the board. For example, I can show you, wasn't planning on going too much into this today, but if I just show you quickly here, if I drop in on this, a quick drawing. So for instance, some CAD files here. So I'm going to bring in this small drawing of a flat, for instance, and I'm going to drop in a distribution board on here.
So for those of you who are listening, this is drag and drop electrical design where Spencer's pulled up a CAD drawing and he's now dropping in some equipment.
Yes, sorry, I'm not used to doing like the podcast stuff, so I'll try and be a bit more descriptive.
No, it's
so
fine. It's fine.
I have brought in a drawing into the software now of a physical floor plan of a particular location. And what I'm going to do is I'm going to add various elements. So for instance, now I'm dropping onto the screen distribution board. So I've just dropped that in there, and I can also link it into my schematic, what we've built up in there. So the software is going to relate those particular items. So for instance, here, if I select this DB now, I'm going to say I want to link it with this DB1. I can assign it, and it will start adding references and details based upon what I've got selected in there. Now I'm going to drop in a new ring circuit on here. So I'm going to create a new circuit after dropping in. I'm just going to give this a nice new CAD layer because we're in a CAD environment. So we're going to add it as a CAD. This smooth that will. And I'm going to give it a nice fancy another color so we can see the differences on there. And the reason why I'm doing this is just to sort of answer your question there, Craig, in terms of things about the lengths and how they can calculate, because this is going to give us a nice visual representation of why we're calculating it in that way. So here, go to my sockets and grab sort of standard double socket outlet symbol here. And I can start dropping stuff around. I'm going to add in the wiring. And in this case, I can give the wiring things like an elevation. So when it goes up to the board, it goes down to my outlets. I can set the wiring, how high I want it to go. So for instance, in most domestic properties, floor to in between the ceilings is usually about 2.75 meters. I think is pretty pretty standard for building. So I'm going to put in 2.75 in here. So I've had that information. And on the symbol here, I've already put in the elevation. Currently, this is set at 400. It needs to be 450. So that's your standard socket height. And I can start dropping in things like sockets here on this drawing now. So for instance, we'll drop one here. It'll add the wires sort of in as the crow flies. And it's just simple drop in wherever I want to put a socket outlet. You see it's sort of adding those wires as I go. So I'm just going to finish that off. Give this one, let's call it SKTS 2, call it general power. And again, I'm going to leave it as a ring outlet. I can say how many watts per point. So depending on your location in the building or in a property, you're going to want to change this depending on it. So for instance, for something like a kitchen, 200 watts per point is probably, you know, pretty good amount, because you're going to be using a lot of high usage equipment being plugged in, things like kettles and toaster. Whereas in like something like a bedroom, you're probably not going to want that much, or even in the lounge, you're not going to be using or drawing that much power. So I might cut that down to around about 50 watts.
If you're upstairs in Neil Bridgman's house, he's got them set to 1 watt, I think.
Yeah, I mean, a lot of the time you see with design, people are putting things like designs as well. Another thing with ring final circuits, I see people do a lot with designs. They put in a current carrying capacity, or they put in the current for usage on it as 32 amps. And then they wonder why their system's completely overloaded. I mean, you go into even your own houses now, if you like most of the stuff on in your house simultaneously, you went and put a clamp meter around your incoming supply, I will be surprised if you're pulling more than 16 amps. Any you know, absolute worst case scenario. I mean, that's a hell of a lot, really. So when you're putting in things like design, even though you've got a 32 amp ring, it's not going to be 32 amps. And I've seen it a lot on things like test certificates and those sorts of things. The maximum demand supplies, like when they guesstimated the maximum demand, they're just adding up all the sizes of the breakers, but it's never going to be anywhere near that, you know.
No, that's a big problem out in industry at the minute with heat pump installers, because obviously they're not au fait with electrical design, and they're working from the on-site guide, very out of date numbers, and they're coming to these figures that are really, really high, and then trying to spec a heat pump and not able to get it in the window. When if you actually, like you just said, data logged somebody's supply, or like at my house where I've got the PV system monitoring the load all the time, we very rarely ever get over 20 amps, very rarely. So I mean, the
20 amps is a lot.
Surprisingly low, isn't it, when you think about it?
But I mean, yeah, I mean, 20 amps might not sound a lot, but you know, for a domestic property, 20 amp usage is a huge amount. That's
Mark lives in a mansion, mate.
Yeah.
I wish.
But it's important, taking it back to apprentices, that this is one of those things that when you start doing those demand and diversity calculations, this is about how you start to put it very real, like in a real way, into the actual design and the installation of what you're doing, because you need to know the fundamentals of this information to be able to design it moving forwards. And even if you're not in design yet, if you're an apprentice on site, you do want to be thinking about some of this stuff and thinking about why you're installing certain cables and the reasons behind it.
So I'll put in here about 50 watts a point. I'm going to hit OK here. And what's this going to do? It's just going to create me a whole new circuit in my schematic. So this is one of the ways we help sort of speed up design for people. So if you've got things like floor plans, as you're drawing your floor plans, the software is building your design up in the background. So you can see it's added the socket, it's added how many sockets I had. If I go in here, it's either going to tell me currently I've got 58 meters cable, because it's a scale drawing, yeah, of the location. So, you know, it's taking, like I say, it's all about taking out the heavy load. I've got points here. You can see the wires going from one to here, but I haven't gone yet to the board. So I'm just going to quickly connect those wires back to my board here. So you can see I've got my full ring now, goes around this. So that's bringing me to about 80.45 meters in total for this, you know, about an 80-meter ring for this location. And if I want to see how that's being calculated, we do have these little fun tools like the 3D view here. So you can see here, you can see the height of my outlets. You can see my board, which I'd already preset previously, about 144, which is like the meters 44, which is pretty much the standard for, you know, still approved. Is it still document M?
It is, yeah.
Or, you'll see it in there. And then we've got obviously our socket outlets, which I said at 450, and you can see the route the wiring's taken here on the 3D model. So it's going down to the outlets, coming back up, then it's moving along. And obviously I've done this automated, so it's dropping the wires in as I go, but I could have moved the wires around. I can go with a specific route. So if I need to get around some steel work, or if I need to get around somebody else's work in the property, like, you know, pipes and those sorts of things that are going on for, you know, your other services. You know, you've got that customization available there. So I can see that there is how it's being calculated from one to the other. And I can even go a little bit further than that. So here we've got, this group's information. And I can see for this ring, I can actually see which length I'm going to be. So as you see, our length is calculated going from the board out to our outlet, onto our next one, onto our next one, and it's going the full distance of the ring from the board all the way around, back down, and that's what we're looking at for our calculations there. So going into here, we can see I've got this information in terms of the detail here. And also we've got a little bit of calculation information just below that. You can see I've got my 50 watts point. We've got things like a cosine of theta here, which is power factor. Yeah, have we got any power factors? Things like your power factor, it all comes down to the equipment that you're putting in. Yeah, if you know your equipment, most times, 9 times out of 10, the manufacturer will have that information in the data, what you're being supplied with. So in a domestic location, you're going to be looking at things like your microwave and your oven and those sorts of things. They're going to have like power factors and things on there, and it will be contained in the manufacturer's details. So you can just drop that information in, and it does have an effect on things like our design currents going through them. So I'm going to tell you a little bit now about how this information is going to relate to some of the stuff you did probably in some of the other videos around the design. So up here, we have things like our volt drop. So this is telling me here in this particular box, it's just telling me the volt drop for this particular circuit. So where I've got this distribution board that we put in, what my volt drop from this distribution board to the furthest point on this ring circuit that we've currently done. What's my overall volt drop to there. We've also got next to it the total volt drop from the supply. So currently my whole voltage drop from my supply all the way to the end of the circuit is around about 1.717 volts. Yeah. But this circuit, this individual circuit, is only 0.51 volts. Yeah. So we can see that staging as it goes up there.
That's really useful for learners, and even the picture as well. I'm just going to interrupt you talking about the volt drop, but I like the images around the reference methods too. So if you are a trainee or an apprentice and you get to look at this in your college or training environment and you're unsure about what your reference methods are, and you're listening to this as a podcast now, there is actually an image which shows you. So that's really good. Sorry, yeah, Spencer, carry on.
Yeah, we'll look a little bit more at that as well as we go through. We've also got information about obviously your current that's being drawn here, local kVA. But you'll notice that none of these boxes are editable. We'll talk a bit more about these boxes that go down here. But these boxes are all related to what properties you've set in. So what kind of conductor you're using. It's taking into account the fact that, those conductors have resistances. It's taking into account your protected device and the size of the detail that you have on there. It's taking into account things like your correction factors, your reference method. Below that, we have our XP values. So here, so we need to comply with certain XP values. You've probably seen this in Appendix 4. I assume you guys have gone through the Appendix 4 information, like, and how we're looking at, building.
Yeah.
Well, first of all, here we have our design current. So I can see the design current based upon the number of outlets and how I've set that information up in watts in terms of that detail. And then I can see that I've got this equity value here. So we know that this design current has to be less than equal to the size of our protected device, or in this particular case, our IN value. So IN is always like a fixed value in protected devices. You may also see from time to time where it says IR value, which is any protected device can have two values in terms of things like MCCB. So your IN is like the fixed size of the device. So for instance, I had a 200 amp MCCB, but there's a setting on it, which is the IR value. I can turn that device down to, let's say, 125 amps. Yeah. So your IR value, which would then appear here, would be whatever value that you've set that to. So in this case, I'm just using a fixed device like an MCB here at the moment, which is a general standard device. So a 6 amp MCB will always be a 6 amp MCB. You're not going to be able to set it to a lower value. So we're going to see an IN value here. But I can see because of the equity, currently I've only got a 6 amp device here, but that passes. But we'd never really use a 6 amp device on a ring circuit for sockets or power or anything like that. So again, even though the software's telling us that we're okay here, engineering judgment tells me it's not really right. I need to change that device. We need to make sure that we've got a larger device in there because you could have more things going on there. And there are standard ways that we can set up information. You can see around that in the inside guide. Well, And then next to that, we've got what our minimum IZ value is. So our minimum IZ is talking about what the minimum size of our conductors must be in order to comply with the regulations. So in this case, currently, my minimum IZ needs to be 3.75. Now, this is because we're looking at a ring. So our conductors are in parallel. So our minimum IZ currently is about half the value of our IN value as we go there, because we're looking at parallel conductors. But we've also got to take into account other things. So in terms of things like correction factors here, we've got things in here about correction for operating tension because of the volt drop, and those sorts of things. So this is usually things that aren't often considered as part of like the handwritten design elements, but it's things that we can consider as design. And there's various standards related to that information. So for instance, if I hit this information icon again here, you can see that this is actually something we do take into account in Appendix 4, correcting for temperature of that based on the volt structure system. Yeah. So this value has added an additional bit. This is 0.75 to, now we've got various correction factors in here, and correction factors are always specific to your reference method as well. So you've got to bear in mind that the correction factors will change based upon your installation. So for instance, this is just a standard cable running in a piece of conduit at the moment within a masonry wall. So our correction factors will be specific to that. If I change this to a flat twin and earth cable, because we're looking at domestic, it's going to be most likely some form of flat twin and earth. Now I've got two types here. The first one is we've got the 70-degree flat twin and earth. Now, if you're using low smoke zero halogen and those sorts of things, they're actually thermosetting cables, so they won't actually be 70-degree cables. They'll actually be 90-degree cables. So here I can go to the 90-degree. But what I've also got is the ability then to run that to 70 degrees. And again, this is something that's actually very, very important to consider as a designer. Things like your socket outlets in the domestic property and your protected devices and those sorts of things, they'll only be rated themselves to 70 degrees. So when you use something like a 90-degree cable, you actually have to then back and derate that cable to 70-degree value. Changes things like the current carrying capacity. So the current carrying capacity for a 90-degree cable is much greater, but you have to limit it to 70 degrees because of the type of terminations and connections like the way. So there's other considerations there. So here I've automatically told the software previously that any 90-degree cable I put in, I want to derate to 70 degrees, because in 99.9% of the cases, even when you get to commercial industrial, it's very rare you come across a protected device or a specific type of connected equipment which isn't rated to above 70 degrees. So most equipment that you'll connect to out there is only 70-degree rated for determinations. So on the upside, though, there are things like the K factors and things that you can affect that can affect things like your adiabatic equations and those sorts of things down the line, which you can still use for your thermosetting cables. It's up to you then, as a designer, to choose how and if you want to do that. Your worst case scenario is always going to be your 70-degree values. You're always going to get the less performance, but there's also cost implications when you do those sorts of things. So lots of food for thought there.
I mean, we have spoken about that on the manual side of doing this as well, Spencer. Yeah. So it's great that the software is pulling those things in and doing it much quicker and kind of guiding us a little bit as well. I think that's really nice that it's not just trying to replace us as engineers and electricians. We said that right at the start. It's a guiding tool, and it does it very well.
So I've got my flat twin and earthing. And I'm going to stick it in reference method 100, installation method with our plasterboard, up to 100 millimeters. Because with that value, I do know that if I go to my 2.5, I'm still going to get my 20 amps. I've got 21 amps current carrying capacity there for a 2.5 on that cable. You can see that information just pop up here. Currently, I've got this 1 mil, so you can see I've got 13, and we can see that our values are actually complying here. Like I said, these aren't compliant with the requirements of those certain regulations, so we do need to take into account. There's also some tables as well that you see in BS 7671, which actually specify minimum conductor sizes for certain types of circuit, like power circuits for socket outlets and those sorts of things. Actually, the minimum size you should be using is 2.5 anyway when you look at those sorts of tables. going in there. So here, I'm just going to select the 2.5 there. And you'll see that information up here and changes accordingly. Below that, we have impedance values. So you've got Z1, Z2, Z3, or Z1 plus Z2. Effectively, what we've got here is your R1, R2 values and those sorts of things when you're doing like your ring circuit testing, those sorts of things. So this R1, R2 value is roughly going to be about the same value that you'd expect to test when you test this at 80 meters long. This is the value that I would expect to get on my my continuity meter when we're doing that ring final test there. So you can match that information as well. We've got that detail there. We have things then around our fault levels. So here we can see for the furthest point on this ring circuit, our fault levels are now quite low in terms of those values. And that's going to affect things like our disconnection time with our protected device, because the lower this value is, the longer it's going to take for that device to actually operate. And I'll try and explain that a little bit better when we look at the selectivity curves. Here then, so I've set that information up, so I'm quite happy. I'm going to go to the protected device. I'm going to set our protected device up because I've only got a 10K device. And like I said, we've got quite a bit of fault current where this board is actually located. I've got 10Ka. Now I'm going to set this up for the time being with just a generic device, but a little bit later on, I'm going to come back to probably one of these and I'm going to set the manufacturer specific device in the system. So you can actually see there's quite a big difference between manufacturer information and the standard worst case effectively information you see in BS7671 for the maximum ZS values and things like that.
That might be a comparable design being specific on another evening, potentially, of going, well, here's how we done it on generic and then here's how we done it on, because I think that'll be interesting in your selectivity studies and stuff, how much difference that has to it with what it does.
Yeah, selectivity is its own dark art altogether. I mean, I can literally spend an hour talking about nothing but selectivity because it's such a broad subject. There's a lot there for consideration. But in this case, I want an RCBO because we're going to do ring final circuit here, so I'm going to select an RCBO type device. Now, actually, on the generic ones here, I don't actually have a compliant device. So generally, 10Ka for RCBOs is pretty much a lot of the limit there. So taking that into consideration, I'm going to cheat. I'm going to add this 32 up here. I'm going to leave it as 11K. Now, there are other things related to manufacturer's data, things that we refer to like backup protection and those sorts of things, which can actually be we're going to keep this up today. So I'm going to just apply what I've done so far on here. I'm going to go back to my supply and I'm just going to adjust the values down slightly. It is a bit cheating. So for instance, I'm going to drop these to 9K so I can use my 10Ka devices.
I don't know about you, Mark, but I've never done this. Have you?
No, never. Never done that.
I get this. We're making this up as we go along. So we've not got something that we've got something we can go and compare results with on a site. We can't go and test something to say, right, this is our installation. We just pulling together here. Yeah, don't do that in the real world. But here now, if we go through, as you can see, my K ratings now dropped quite considerably. I can see at my protected device now I've got, a much lower fault level available. So, these go in there. I added that information. Currently, I've only got a 6Ka device here, and I need to have at least figure, so I can go now. You can see here we've got my 10Ka. So earlier on, all of these were red. So again, the software is just giving us little hints to say, look, if you select this device, it's not going to comply. You're still going to fail this check. Here I'm going to go for 10Ka. They're mostly doing Type Cs now in these domestic boards. Are they still doing Type Bs?
Type Bs mainly in the domestic boards still.
Type B, drop a Type B in there. I will say, again, with all these things like heat pumps and those sorts of things going in, brush up on your types because it's quite important in terms of reference to the type about how that curve behaves in relation to the amount of current, particularly things like startup currents and those sorts of details there. We probably won't look at that too much today. Maybe we can follow it up on another
Yeah,
podcast.
sure. I mean, if you're happy to come back, Spencer, we can go into this in more detail in specific areas, because it's really hard to give a broad coverage without diving down rabbit holes everywhere with this
It
software.
is. I find myself, I keep doing it. I'm trying to bring myself back from time to time. But yeah, there's a lot of consideration there. So making sure you're selecting the right type for the piece of equipment that you're using. And again, a lot of the time, if you go back to the manufacturer's data is really useful. Yeah. If you have the information about the piece of equipment that's going in, read the bit of information from the manufacturer, because it's going to give you a lot of really good, useful information as a designer on things to select. And over time, you know, as you keep doing these, you'll see the patterns. You'll know, right, I've got this type of equipment. It's XYZ kilowattage. It's going to be this sort of size. You know, the manufacturer is going to say I want a type C. And when you go through that information, you're going to see, you know, that's going to follow through as you go through there. So just getting used to that level of detail. RCD class, again, this is a big subject out there at the moment, particularly since, you know, the 18th edition come out. Looking at your RCD classes, again, we've got a little information in here. We've pulled information and put in the information around what those different classes are, where you might want to use them. So again, looking at that information is going to be quite important. And when you use certain types of RCD, most of the time now, I think a lot of the RCDs out there, I think majority of them are coming standard as A type, aren't they? You might come across obviously in existing installations AC type RCDs, but again, it all comes down to the type of system it's connecting to. If you're just supplying kitchen ring, which is going to have kettle, you know, toaster, fridge on it, those sorts of things, there's going to be very little DC on that system. So, you know, AC is probably still relevant for those sorts of installations. But if you start adding in the photovoltaic systems and your EV charging points and all this new smart technology, smart televisions, those sorts of things, you need to be looking at moving away from them, because naturally that can have a knock-on effect in the long term, particularly if people are updating the technology in the house, but they're not updating the protected devices relevant to it. If something goes wrong, you know, something might not do what it's supposed to do in terms of switching off or protecting that. So quite important to consider those. So selecting your RCD type in terms of the class here is quite important. We've got a number of class information in there, and it's all standard to IEC and British standard information. So again, you see relevant info. AFDDs.
Leave it off.
There is a lot of detail out there now. FDDs, as of the last amendment, they are pretty much required in domestic installations, or residential dwellings, those sorts of things. So there's a lot of words for a domestic or a house or a dwelling or those sorts of things. So there's specific regulations now in relation to that. And again, if hit this information marker here, we can see some information around that. You know, so we've got high risk buildings, multiple house operation. This terminology has actually changed, but it hasn't changed in the latest version of BS 7671 yet. I think it's just referred to now as HRB, higher risk buildings. Yeah, not high rise. It doesn't just high risk buildings don't just include buildings that are tall buildings, high rise buildings above a certain thing. There are category now just for high risk buildings, and that can be, you know, you can still have a bungalow as a high risk building. It depends upon, you know, the application of that, what's happening there. So we've got all this information again, so we're going to drop that in. And for today, we'll just tick that box. So yeah, we're going to throw AFDDs in there because, you know, of course somebody wants to spend 150 or £1 on, what is it? I've got to be honest. Like I say,
They are getting a little bit cheaper now. They're under £100 generally, just about.
Okay. Blimey, still a lot though, isn't it?
Gents, I am just as a bit of a thing in about 5 minutes, so I'm gonna have to end up bowing out, unfortunately, because I've got a sick little one at home who I can hear giving the missus a load of grief, and I'll have to go and help shortly.
Sorry to hear that.
No, that's fine, mate. If you've got to shoot off, Craig, that's not a problem. You go and take care of the family. Just want to thank you before you do go for coming on the podcast all year and giving us your time. You've been an absolute superstar, and I know lots of people listening along. I've been very grateful for that. So thank you very much, Craig.
Thanks all. Sorry I've got to bow out. I will watch the rest of this to why I know the bits I've not done right, which I've realised so far. Otherwise, have a good
Nice one,
Christmas
Craig.
all, and I'll catch up
Have a
with
good
you.
one, mate. Take care.
Just,
Yeah. So we set up a protected device. So we've got our AFDD, we've got an RCBO, it's type A. We know we've got an fault level at the protected device. And here we can see information about whether we complied with certain information of regulations. So here we've got 522.6201, 522.6.204. And this is obviously in reference to, is it buried in a wall? Is it within the correct zone of the building? So is it, within that sort of 150 mil of the edges, or run horizontally with the socket outlets? Does it have an RCD in place? So this tick box is all about confirming as the designer that the design intent is that it's to be run in that fashion. Yeah. So in this case, I'm going to say yeah. Just another thing, you'll notice here that these are 201, 204. These are actually UK specific. Yeah. Any 200 number in the BS 7671, remember, whenever you see that anywhere, it's a UK specific regulation. So it wouldn't necessarily be in the continent or another location. No.
Good point to emphasise there. And with it being a ring final, it's probably to do with that more than anything else, because no one else uses them apart from us, do they really?
Yeah, I don't think there's anywhere in the continent that they tend to use them. I think rings do have their place though. I mean, they're very useful for things like data centers and places where you got computer rooms and things with high conductor currents when you turn them on for earth leakage and those sorts of things. I think they've got their place, but I don't believe in them in domestic anymore. Not for a long time.
There's definitely two camps on that, isn't there? I think if they're
There
installed
is
well
there
and
is
left
two.
alone, they're perfectly safe and serviceable circuits. But
Yeah.
DIYers tend to have a medal from time to time, don't they? And these things never get left as they were first installed.
Yeah. So I've placed all that information. You can see that my warnings are all disappearing as I go. So the software's been helping us along the way, put in the various details. And as you can see now, I can finish that off, and all my details will appear on here. It's a little bit messy in terms of the level of information. So I can move this around. We are working in a CAD environment, for instance, here. So if I want to move something, I can do that.
Fantastic.
Move things around, and we've got lots here. Like if I haven't got enough space in here for all this detail, I mean, it is a bit clustered there. I'm just gonna sort of give myself a bit more space there, and spread things out, stretch it, make it smaller. There's so much customization to add, and we try and keep the CAD tools relatively simple as well. So if you've got tools in there, you'll also notice things like my symbols. When I selected socket kind, it's changed my symbol relevant to the socket. Again, some customizable. You can choose your own and make your own default information details there as well. But we do have a lot of basics in there, which are built upon standards. So there's actually a British standard, an IEC standard for symbology in kinds of drawings, and we've taken all that and placed it in here. It's very out of date. Last time it was updated was in the 1960s. Yeah, but a lot of
Ain't
it's
broke, don't fix it. It's like
yeah.
we all know what
Well,
these things look
you
like,
say
don't we, on
that,
these
but
designs?
you say that, but take a look at the things like we're coming onto market now. We've got no standard symbology for an EV system, for
True,
EV or AS,
true.
or those sorts of battery storage systems, or photovoltaic panels, or we've got some things that people have made up and commonology with inverters. So for instance, I'll just drop in actually while we're at it, things like a solar inverter. So here I've got an inverter, an AC rectifier, solar PV inverter. So we've added some details in here. You can see we're going from AC to DC. Yeah. Relatively standard simple. And that's just really been derived from things that people have been using for like UPSs and those sorts of things. Same effective principle in reality. But yeah, it's those sorts of symbols that the people are sort of falling back on because they're pre-existing. details there. So I've got
That's really good. I'm just conscious of the time to fence, so we've kind of reached the hour limit where I think lots of people will be tuning out. So if you're happy to come back and delve into some of this in a bit more detail, that would be incredible. But I appreciate your time is a finite resource, so don't commit to anything you're not happy to do. But if you could just very quickly share maybe the certificates and how that links across to the design, because I think people would be interested in that. Definitely at a kind of electrical at a domestic level and apprentices. So does this link over into the search pack?
Yeah, so there are certification which is built in. It all comes through on mobile as well, so you can send all this out to a mobile device and fill out your test results. Also, if you are going to an installation where you've never been to before, if you create something from blank in our mobile app, send it to the software, it will reverse engineer your design and schematic from the test results to the details you brought in, because everything's calculable. Yeah.
Oh,
So
wicked.
yeah, everything grows bi-directionally
So if
within the
I've
software.
if I've got existing data on a test certificate, I can load it in here and it'll produce a schematic because I didn't know it would do it that
Yeah,
way
you
around.
wouldn't do it directly here in the UK forms, you do it in the mobile app. Yeah.
Okay.
So
Okay.
you build it all up in the mobile app as a basically like you were building up an EICR or an installation certificate, and
Yeah.
everything will there build reverse engineer, and we'll take things like the R1, R2 values and calculate things like what the the circuit length and those sorts of things are based on
Oh,
that
that's really
detail.
annoying because I just did that and then drew it all out separately as a new design as well. So I never knew that. That's
Yeah, I could have saved you hours.
could have done. Could have done.
Um, So here, yeah, I can create a new certificate. We've got various ones here: emergency lighting, fire alarm, and then obviously what I refer to generally as the Holy Trinity, which is the installation certificate, the installation condition report, and the minor works in there as well. So, for instance, here, if I'm sending this out and I'm going to do then an installation certificate based on this design, I can select this here. And when we go in, you'll be able to fill out all your data details. You can also predefine things like your clients and certain things in there as well. So a lot of this information is auto-filled. Again, when we go to our page 2, things about our supply, I can input that information directly from the design. So it'll select certain details and information. Obviously, you can test against that detail then when it goes in and out. When I go to things like my distribution boards, it's going to show all my circuits. It's also going to pre-populate things like the fact that I've got RCBOs in there, the size, the type. So where there's information in the design that we can use, that's going to be pre-populated. You'll notice, however, that obviously all the test result boxes will always be blank. Yeah. So the test result boxes, that's the information that you then go and fill out. But the heavy lifting of having to then go and fill all the various little bits of detail out there already pre-done. And then there's a lot of features in here then to print that. So if you want to stick a label in the board, or if you're going to do a print off and stick it in a wallet, pop it on the board, you can do. Or if you produce a set of information, like a handover pack, effectively. Because some of you might have noticed that, in part 5, some of the label details have actually changed, and whether or not certain labels you don't actually have to put on a board anymore because it's all contained within that information, that handover pack detail. So you don't have to have 50 million boards labels on your board and those sorts of things anymore. There's simplification that can go into there, and we can produce that information in here quite easily and quickly. So there's a lot of key details in here. Now I'm going to go and create from here a something else in here in terms of an EICR. Because the EICRs in electrical OM have a lot of additional features that you don't see or get anywhere else. So, for instance, the big ones here about observations within there. So, something that we do differently to everyone else is you can set up things like observations and limitations based upon individual boards, based upon specific circuits, and it all references and links across in the certification for your final print off information and details as well. So, for instance, if I go to a distribution board here, you can see I've got observation limitations. So, for instance, for the socket outlet, I can add a specific observation. This works the same in the mobile app as well, and you can take photos and attach that information details there. And then I can link this to a specific inspection item straight from the observation. Yeah. So for instance, here, I'm going to go down to our final circuits, and I might put down identification of conductors, not C1, C3. and I can add in some observations. I'll just put some gibberish in there for now. You can add photos and attachments directly in here. So you can add an attachment. An attachment can be image files, any sort of type there. And we can put that information in here. And when I press OK here, when I go now to things like our observations page, I can see the full list of observations. But if I go to the schedule of inspections, it's predefined and filled out the outcomes in our schedule of inspections based upon the fact that we've got, different observations there. And if I've got more than one observation, I can see how many observations are connected to that specific option. And if, let's see, at the moment I've got a C3 here, if I had a C2 or a C1 on that one, that particular option, probably wouldn't get that with identification of conductors. But if you did have a higher code, this would adjust to the final outcome would be the higher value of that particular option. So it's taking out a lot of the heavy lifting. As you're filling out your observation, the information where it can be used elsewhere is being applied as you go. Also, it goes further than that because we can also do things like rectification details. We can add additional photos to show that something's then been done, and that will be shown in the report. You can add that information. And if I've created another certificate, so for instance, here I can add a cert. So previously I created an EIC. I can actually link that then directly into the EICR, and it will be attached to the bottom of the EICR when I print it off. So then it gives you that full history of, right, this is what we found was wrong. This is how we repaired it. Here's the certificate or the minor works or whatever it is that you'd attach there. And the software will compress all that information together for you in a single report that can go out to the client with all that various information predefined in there. So, again, you're not having to reference and bring in different pieces from different places. It's all getting built as you go through there.
That's solving a problem for us as electricians, especially with the PRS thing that came in and landlords with the ICRs and then numerous remedial repairs and wanting certificates. They just wanted EICRs that said pass on them at the end of it all. But the actual audit trail of those certificates for the letting agents and stuff is really important. So that is great that it's included in that software. It solved a problem for us, certainly, last year, more than this one.
Yeah. If you do come across, though, things like regular observations, which are things you're coming across quite often, you can create your own templates. So every time you add an observation, you can add your own templates and you can predefine information relevant. You can connect it to a specific item. You can then set up your own classification codes for that particular issue. So then obviously you've got this level of conformity across the board. So if you've got multiple guys out there working, doing certain locations, they can select from a common list. They can go into that information. They can put that directly in the report. And then that way, you get that uniformity, that nice tidy finish going on there, which is something you only really get from, from the likes of digital systems, really. So yeah, there's a lot of stuff in there.
It's brilliant software. I'm a huge fan of it, and I know there's absolutely loads that we could dive into and cover now. Is there anything you want to talk about before we end this one tonight, Spencer? Anything else you want to pull out, or I can just point people at your existing content that's already available?
Yeah, we have. I mean, I've tried not to make this, a blow-by-blow guide. I've tried to keep a bit of an overview going on. There are some really good videos online. Like, say, we've got the learning and training channel, which basically goes through all the basics of the software. How do you create a supply? How do you do a distribution board? What are the difference between a few different connection types? How can you go through design? I mean, I touched on some of these elements here in terms of like the active values. I mean, I'll go into a lot more depth in these. I'll talk through them one by one in the video so you can understand what that information is, where it relates to, how it connects to the design. Like I said, the knowledge base is really good in terms of the information. Got a guy, Mert, in the office. He produces a lot of that stuff on the knowledge base, and he's absolutely top notch in terms of that detail and information. And as this is for things like apprentices and those sorts of things, talk to your colleges. ElectricalOM provides the software to colleges and training providers absolutely free. As many licenses as they require to go through and obviously give people a learning and learn about design and those sorts of things the opportunity to actually use software that's being used out there in the marketplace. Because at the end of the day, if you move on and you go to a firm or a company where you expected to design, you'll be using something like this. Rarely be asked to do something pen and paper these days. But don't dismiss sitting down and doing it pen and paper from time to time, just to reassert and affirm, and even just to check that the results coming in and out are what you expect them to be. Um, that's an important piece of engineering ability and judgment, is to understand that what you're getting, have confidence in what you're doing. So absolutely play around with it, try it, try and break it.
I've certainly tried to do that. It's broken me more than I've broken it, I think. That was a really good overview, Spencer, for any of the apprentices and people who are new to the product watching this, following along. There was some nuggets in there as well that are helpful more widely. So thanks for giving us your time to come and talk about that. And I know from my visit to MK College recently that they've got one of the free licenses you were talking about, and they are actually using that and demonstrating it with their students. That was nice to see close up. Richard, you've been watching away down there through the course of this. Have you been convinced to the benefits of software? Are you going to give it a run out yourself and put it through its paces?
Yeah, I mean, it's very, very comprehensive. Obviously, we are taught from an early age to design to the worst case scenario. So your 0.35, external impedance for your PME system and et cetera, is worst case scenario, isn't it? Which is generally what you are working to, unless you've got specific information from the DNOs, which we generally can't get hold of. So
where that comes the problem, where that comes the problem when you get to this sort of stuff.
Yeah, of course. Yeah, you'll never get it to work, will you? Which,
that's where you get the problem with it. And it's when you get to things like your rings and you get your 32 amp circuits, your ovens, and you've got 40 amps on there, or you've got a supply out to a garage, which is like a 63 amp or something along those lines. You just simply won't get compliance. It won't work. And
you will, but you'll just be installing some ridiculously large cable when there's no need for it. But in the absence of any other information, currently that's what we're working to. And Mark touched on obviously the out-of-date diversity, guidance, which I know that the IT are currently working hard to update. But that's what we've got. That's what we've got at the moment to work to. So, but it's very, very comprehensive. It's excellent. It took me some time to get my hand around it, and I know that my colleague David loved this because he's a designer through and through. But it's amazing, really, really clever bit of kit. I love the way that you can create, wiring diagrams and illustration of the installation method and the individual, legs of the ring and all that. This would have been a godsend when I was delivering the hotel project on the old apprenticeship framework, where they had to design a number of circuits, and it was all done by hand. We still got the stencils to draw out all the symbols that, as you say, haven't been updated since 1960, etc. But what a great piece of kit, and fair play to you for giving licenses out to training providers and colleges. More people need to be, or more manufacturers need to be like yourselves, forward thinking. And you know what? If they're likely to use it during their time, then they're likely to use it when they qualify and maybe set up their own companies. But, hopefully we can do more work with more manufacturers in the future to do the great work that you've done there. But I'm looking forward to the next one. I've kept in the background, and I've just been trying to keep up with everything you've been doing because, gosh, the options are never ending, aren't they? What a great piece of kit. Yeah. I'm looking forward to having another go, getting a bit more involved. Yeah, brilliant. Absolutely love it.
Steep learning curve with that product. I know Jamie wanted to come on as well, one of the other hosts of the podcast in the past, because he's really keen to pick up OM and start using it himself in his day job. I think there's lots of people who have kind of gone on that journey with software. I was probably maybe 4 or 5 years ago when I started looking at using software for some bigger systems we were designing. I think a lot of electricians are going to be on that path anyway because of the introduction of PV, EV, and all these things. Even at a domestic level now, installations are getting more and more complex. So just having something of an oversight to count and measure your mistakes you could make. If you're a small contracting business and it's just yourself as the designer, having a bit of software to help you, I think, is a great thing. So yeah, do check out the links. I'll drop everything in.
Yeah, sorry. So we haven't even touched on things yet for the photovoltaics and those sorts of things.
No.
I mean, looking at things like voltage and those sorts of things, there's nothing in any of the guidance out there about how you're supposed to be calculating and doing those sorts of things. There's
No.
lots of stuff that we've had to go away and actually look at and build math for to actually take into account these things people are only thinking about now, after the fact. And it's it's a very interesting time, and I think standards are starting to struggle to keep up with the technology.
This is it. A lot of
And
it is
everyone complains about
manufacturer
soft and all
driven.
these.
It is manufacturer driven, a lot of this stuff.
Yeah, and people complaining about the standards getting every 4 years you get a new version of standards, but realistically, every time we do it, we're already behind by the time a new standard comes to market, and it's the pace of technology now. It's immense. I mean, it's absolutely mind-boggling about the changes that are going on.
It really is.
Yeah.
And to be fair to you guys at Modecsoft and ElectricalOM, you're one of the ones who seem to keep up faster than most, to be honest. So credit to you for that effort. I want to thank you, Richard, for coming on the podcast again all year. You've been an absolute superstar and a gent. I know you're in a very busy day job at Electric Safety First, and it's not easy to give up the time to come and do these. You show up more times than me sometimes. We've had to drop out because I can't make it, and Richard's still there in the background wanting to do these podcasts. So a massive thank you to all the audience who've listened along and enjoyed these. And the growth in numbers through the course of this year is in large part due to the contribution of yourself, Craig, Richard, and prior to that, Jamie. It is not down to me. I just hit record and enter the conversations. And great guests like yourself, Spencer, for coming on and spending some time with us. I really do appreciate that from all of you.
Thanks for inviting.
And to yourself, Mark, for taking the time out. What you've achieved this year and previous years with Apprentice 1-to-1 is something that should be applauded, and that's from me and all the other lads. And I'm looking forward to getting together in the new year and coming up with some new stuff. And we need to do more ourselves as a charity, Electrical Safety First, and we're looking to support learners and training providers and everyday sparks, members of the public. That's what we do. So it's been a pleasure, and I know Dave will be looking forward to doing some more stuff in the new year as well. But we'll definitely come up and see you as well and try and do some one-to-one stuff with some learners that are maybe struggling or sparks. And really good, mate. I loved it. Really been a pleasure.
That's great. That's great. And pass on my thanks to Dave as well when you see him, if he can tear himself away from the bar for long enough. That's great. Dave's an absolute ledge as well. Thank you for tonight, Spencer. I think that's been a fantastic overview of the product, and again for giving up your time to come and chat with us. We can now all look forward to Christmas. We've got like 1 day of work now, so Merry Christmas, both of you and everyone who's listening along to the podcast. If you've got any questions in and around this content, if you want to ask Spencer, Richard, or Craig anything about the stuff we've discussed, drop them in the comments below as normal. And if they don't see them, I'll pass those on as well for them to review. And otherwise, we will see you in 2024 on the next one. Bye for now.
Bye for now.